So today is more U substitution, but we've switched to definite integrals, meaning there's a number at the top and the bottom. There's a limit from 0 to 1, from 0 to square root of 5. So the bulk of it's the same, but we've got to talk about how we handle those limits. And how we handle the limits is change the limits. So we change all the integrand stuff to U stuff, which means we have to change our limits to U limits. Because it wouldn't make sense to rewrite this all in terms of U, but that 0 and 1, those are X values. Yeah. So we have to change those to U values. Ooh. So the extra step today is fix the limits, handle the limits. Always remember, the limits of integration you are giving are in the variable you are given. So that 0 to 1, that's in X. If we want to change this to U, we can. It makes the integration easier, but we also have to change our limits. Well, you can change your limits if you want to. There's two ways to handle this. You can keep the original limits, so you could keep 0 and 1, but if you want to do that, you got to plug the X stuff back in. You got to get it back to the X stuff. The other option is to change the limits to U values. We're usually going to do the second, because AP Test knows how to write questions that force you to do the second. And let's see if, yeah, I'll show you what I mean when we get to the homework. We can write questions that force you to change the limits. Yay. All right, so number one. Job one is don't worry about the limits yet. Let's worry about the inside stuff. So U and du. Thoughts on what U should be?
1 minus x squared.
1 minus x squared, because then du is kind of there. Negative 2x dx. So I need a negative 2 and a negative 1/2. So negative 1/2. Integral. Now be careful, I should not write 0 and 1, because I'm in the process of switching this to u stuff. So the 2x and the dx, that's du. And then I've got u to the 1/2. So I really shouldn't write 0 and 1 there, because those are x values, and I want to be in terms of u now.
You plug it into the
I can plug it in. So when x equals 0, well, I have a formula that will change x stuff to u stuff. So I'm just going to plug those limits in to my u equation. So when x equals 0, u equals 1. So in place of 0, let me rephrase that. In place of x equals 0, I'll put u equals 1. In fact, some people will even write u equals 1 there and x equals 0 there. That's a little bit overkill, but it helps them keep straight what's what. All right, when x equals 1, u equals 1 minus 0 squared.
1 squared.
No, 1 minus 1 squared, which would be 0. That's kind of confusing. So it looks like they traded places, but they did not trade places. The 0 became a 1, and the 1 became a 0.
So now you can flip it and make that 1/2 a positive?
And we have a little bit bonus there. Yeah, we can flip those because that feels out of order. But we can use that negative to flip the order there.
Yay, properties.
Yeah, so use the property to make our life a little bit easier. All right, now this is like first semester stuff.
Yeah, but I slept since it's...
So power rule, increase the power by 1, divide by 3/2. From 0 to 1. So we've switched this whole problem into u. And so we do not have to go back to x stuff. Everything's in terms of u, so we'll be able to get an answer and not have to go backwards. So 1/3, 1 to the 3 halves minus 0 to the 3 halves. That would be a safe stop, but 1/3 times 1 minus 0 is 1/3.
Yay. And should the
No.
limits be like the same relative length between numbers when you change it from x to u?
You mean like the difference between them was 1 and it stayed 1? Not necessarily. It could change. Good question, but could change.
Okay.
The other way to do this, and you don't write this down because you don't have space. I've grabbed a piece of paper here. If you switch it back, so u was 1 minus x squared to the 3 halves, then I can use my original limits. Wait, no, I'd have to, I was too far into the problem. I could have switched it earlier. No, I still could do it there. Just would have, that would work from 0 to 1 because I'd be back to my x limits.
And you don't have to do the plus c because it gives you limits.
Correct, you don't have to do the plus c. To me, I think it's easier to switch it to u and roll with the u's. If only because that's how AP can test it to make you do that. All right, number 12. So don't worry about the limits yet. Let's pick on somebody. We've done enough of these to pick on someone. Famous last words. But I have full faith and confidence in Brooke. She's trying to hide, but can't hide. Drawing popsicle sticks. So, Brooke, what do you think u should be? Very nice. That's a great pick because, Luna, what's du if u is x squared plus 4?
2x dx.
Mm-hmm. So that's good news. We almost match the top. Kira, what can we do to make this a better match for du to show up?
Multiply by 2 and then put the 1/2
Good. So let's see. So 1/2 integral. I'm not going to write 0 to square root of 5 because I'm in the process of switching this over. Du over u to the 1/2. And now I realize I really want to write that as u to the negative 1/2, but that's okay. I'm going to use this notation because it's shorter. U of 0 means when x is 0, or plug in 0 for x, we get 4. So x equals 0 became u equals 4. If I plug in square root of 5, 5 plus 4 is 9. And I get 9 as the upper limit. So now this problem has been completely switched over to u stuff. Everything is u now. So 1/2 integral from 4 to 9. I'm going to rewrite that as u to the negative 1/2 du. And then I'm going to let Mia tell me what the antiderivative of u to the negative 1/2 is. You're on the right path here.
Wouldn't it be 2 u to the half?
Uh-huh. Increase the power by 1. That gets you to 1/2. Divide by 1/2, that's the 2. And then don't forget there's still a 1/2 out front. From 4 to 9. I'm going to cancel the 1/2 and the 2. So really this is just the square root of u from 4 to 9. It turned out to be kind of nice. Square root of 9 minus square root of 4. That's a safe stop answer. So you would be good to leave that. But 3 minus 2 is 1. Again, if you want to switch them back, you'd have to put x squared plus 4 to the 1/2, and you'd have to go back to your original limits. It's like, why are we going to, don't switch back if you don't need to. So a big difference, though, is with the plus c, if it's not a definite integral, if it's indefinite and you don't have limits, you've got to put the x stuff back in because your answer has x's in it. If it's a definite integral, you can get an answer without having to go back to x. You can switch everything to u's and go with that. All right, 13. Why don't, well, we'll get you started. Then I'll leave you alone for a little bit. Isaiah, what do you think would be a good pick for you? I think so. Because Marissa, if u is x cubed plus 1, what would du be? 3x squared dx. Kind of don't like this one because there's a 4 there. I don't want there to be a 4 there. Just take it out. And then I need a 3 and a 1/3. And then I'm well on my way, I think. I'm going to pause, see if you can finish from there. What are you going to do next before I turn you loose? What do you need to do next for this problem?
Change the limits.
Change the limits from x limits to u limits. Plug in 1 and 2. Those are your new limits. Then you're ready to integrate and plug in and see if you can take it from there. One more. Oh, question on that one? Yeah, this would be the safe stop. But that second one would probably be the multiple choice answer.
I have a question.
Yes, sir.
Okay, probably already answered, but on the older, like the problems from yesterday, can you stop when you have like, if your answer is,
Like u to the 4th over 4?
yeah, you have to sub in like the stuff that is u.
It's a great question. You have to get it back in terms of x.
Oh, always?
Yes.
Oh, that's nice.
Yes.
On the homework it had the box in ones with just the u. I think answer.
Did it?
Maybe not.
It shouldn't have. We should convert them to x's.
Okay, I'm on.
How about 14? Let's pick on a few more people here. No, don't want to pick on Belle. She's already working over there. Garrett, what do you think u should be? Cosine. Brandon, what would that make du? Negative sine of x dx, which is pretty good, only off by a sign, so that's fixable. So that wasn't bad. That simplified all the way down to u to the 1/2. But I need to plug in a 0. I need to convert my my x limits to u limits. Cosine of 0, unit circle experts. 1, good.
Looks like it's on the board. It's on the dry erase board.
Sure is, right there. And how about the cosine of pi over 2? That one's not on the board. 0. Okay, oh, be careful. Make sure you put these in the right spot. 1 to 0. Oh, we got this switcheroo thing going on. That looks like they're out of order, but there's a negative sign in front, so I can use the negative to flip them. And now we're home free, like we're done, like with the hard stuff. U to the 3/2 times 2/3 from 0 to 1. I need to slow down. Flying through here. One to the 3/2 minus 0 to the 3/2. The end was in sight, so strong kick to the finish. Sorry, the problem's not a sprint, but you can sprint to the end when you see the finish line. Get that motivation. Today's assignment is worksheet 2, and I want to look at worksheet 2 for a second and show you how we can force you. Yeah, number 8 looks bad. But look at 6 and 7. 6 and 7, let's look at 6. This is where we can force you to change the limits from x limits to u limits. In fact, before I even work this problem, the x limits are 0 and 2. So, I mean, it's possible that they could turn out to be the same, but I'm pretty sure that limits of 0 and 2 is not going to be right. So I could probably throw out b and d as it is. So plug in the top limit, I get 5. Plug in the bottom limit, I get 1. So I know I need to go from 1 to 5. So I'm already down to C or E. Let's see, du is 2 dx.
So you'd have to put a 1/2.
So I need a 2 on the dx and then a 1/2 out front. And there's that 1/2 out front on choice C. So there is almost always one of those on the AP test where you actually don't do any integration, right? We didn't get to the spot where we actually integrated that. We did the switch. We switched everything from x's to u's and then stopped there. Number 7 is similar. Make all the swaps, but then you don't actually have to. 8 looks ugly, but it's rigged to work out. We should probably do 10, 11, 12. If we don't, let's do 10, and we'll worry about 11 and 12 tomorrow. So number 10, let g be a continuous function using the substitution. Okay, so this isn't terrible. It tells me what substitution to use. 2x minus 1 is u, so that's g of u. That's why they all have g of u there. du is 2 dx. So I need a 2 on the dx, which means a 1/2 out front. And then I just need to switch the limits from x limits to u limits. So actually this wasn't as bad as I thought it was going to be. It looks ugly the way it's written, but you start plugging things in and it's not too bad. In fact, I'm already down to b and d. And in fact, b didn't switch the limits, so I'm guessing it's not b, it's probably d. U of 3, if I plug in 3, I get 5. So that top limit should be 5, which is enough to tell me it's answer D, but I plug in the bottom limit. 4 minus 1 is 3. That's the bottom limit. So it's answer choice D. So 10, 11, 12, they look really bad, but when you start plugging things in, it starts working out, especially since it's multiple choice. Not as bad as it looks. I suspect we'll have to do 11 and 12 tomorrow. That's fine, but I want you to try them first. All right, so today's assignment is worksheet 2. More practice with U substitution, but it's U substitution with definite integrals rather than indefinite integrals.